Hello everyone, I welcome you all in this C programming and data structures lecture. In this presentation, we will write a program to convert a decimal number to a binary number by using stacks. So without any further delay, let's get started. First, we have to understand the decimal to binary logic, how to convert a decimal number to a binary number. It's very simple. Let's say we are interested in writing the binary equivalent of the decimal number 77. For this purpose, we have a simple procedure. Divide the number by 2, store the remainder somewhere, repeat step 1 and 2, means these two steps, until quotient becomes 0, print all the remainders in reverse order. Okay? This is the procedure we must follow in order to convert a decimal number to its equivalent binary number. Fine? Here we first have to divide the number by 2 because we want to convert this number to a binary number. That is why it is important to divide the number by 2. Here, binary is the word, right? And 2 means binary. Store the remainder somewhere. It is important that we must store the remainder somewhere because that remainder represents a bit of this particular number. After this, we must repeat step 1 and 2, means we have to repeat these two steps again and again until quotient becomes 0. And then we must print all the remainders in reverse order. Okay? Let's see how to do this procedure. This is like a prime factorization, but every time we have to divide this number by 2. Okay? So let's place this number over here and let's try to divide this number by 2. We know that this number is an odd number. Therefore, we will get 38 as a quotient and we will get 1 as the remainder. Fine? Because 38 into 2 is 76 and 76 plus 1 is 77. Fine? After this, we must divide this quotient by 2. And here you can see this number is an even number. After dividing this number by 2, we will get 19 as the quotient because 19 into 2 is 38 and remainder must be 0. Every time we will always get either 0 or 1, right? After this, we must divide this number by 2. This is an odd number. Therefore, we will get 1 as the remainder and quotient must be 9, right? So 9 is the quotient and remainder is 1. Then we must divide this number by 2. We will get 4 as a quotient and remainder must be 1. This number is an even number. We will get 2 here as a quotient and we will get 0 as a remainder. Then we will divide this number by 2. We will get 1 over here and 0 over here. Right? After this, finally, we must divide this number by 2. We will get 0 as a quotient and 1 as the remainder. As we have obtained 0 over here, we must stop at this point. And then we must print all the remainders obtained in reverse order, which means from bottom to top. Fine? We must not print all the values on the screen from top to bottom. We must print them from bottom to top. So the binary equivalent of this number is 1001101. Remember that it is not 1011001. Therefore, 77 in binary is 1001101. Okay? I hope the idea is clear that how to convert a decimal number to its equivalent binary number. Now we are interested in writing a C program to convert the decimal number into binary. For this purpose, of course, we have to include these two libraries. And here I have defined max, and max must be 100. It is just a selection of the number. You can choose any number of your choice. After this, I have declared this stack array, and to this I am passing max. And here we have a top variable which is initialized to -1. We are using stack, of course, right? And these two are global. In this main function, I have declared a dec variable, and after this we have this printf function. I am simply asking the user to enter the decimal number. User will enter that number and it will simply get stored inside this dec variable, right? You can see this is how the output looks like in console window. Enter the decimal number, right? User will enter the number and we will store that number inside dec variable. After this, we will call this function dec to bin. This means decimal to binary. We will simply call this function for the purpose of converting the decimal number to its binary equivalent. Here we will pass dec. That means we must pass the decimal number to this function. Now it's time to write this function. We must always remember the algorithm behind this function. The actual procedure is divide the number by 2, store the remainder somewhere, repeat step 1 and 2 until quotient becomes 0, and print all the remainders in reverse order. Now let's convert this to decimal to binary algorithm that we will use in our program. This is the algorithm. Divide the number by 2. Obviously, we must divide the number by 2. Then we must have to store the remainder inside stack. Okay, we will immediately store the remainder inside stack. We will use stack as a storage entity. We will store the remainder inside stack. After this, we will repeat step 1 and 2 until quotient becomes 0. And then we will pop all the elements out of stack and print. Simple. Stack will help us in printing all the numbers in reverse order. Okay, so stack is used for this purpose. Now here is our dec to bin function, and you can see here that this function will receive some value, and that is obviously a decimal value. You can see variable n is declared over here and it will receive this value 77 from the main function, right? Here we have this piece of code which will help us in converting the decimal number to its equivalent binary form. Here I'm using a while loop and I'm checking this condition. If n not equal to 0, if at all it is the case that n is not equal to 0, then we will continue. Otherwise, we'll get outside of this while loop, right? Inside this while loop, I'm calling push function for the purpose of immediately pushing the remainder onto stack. That's why you can see I have passed n mod 2 to the push function. After this, I'm using this line of code, that is n equals to n divided by 2. We must update n by 2, right? This is important. Let's try to understand this code step by step. First, we'll check this condition. Is n equal to 0? You can see n is not 0. Therefore, we'll get inside this while loop. We will call the push function, and to this push function, we will pass n mod 2, right? N mod 2 gives 1. If we divide this number by 2, we'll get 1. Now it's time to push this element onto stack. And this is how it looks like. This is the state of the stack after calling push function. Then we will update our n variable by n by 2, right? What is n by 2? N by 2 gives 38, right? So the value of n will get replaced by 38. After this, we'll again check this condition. Is n equal to 0? N is not equal to 0. So we will continue. We will push n mod 2 onto stack. What is n mod 2? This number is an even number. Therefore, we'll get 0 over here. We will push this element onto stack. Then again, we will update our n variable. This becomes 19. After this, we'll again check this condition. Again, this is not equal to 0. We'll get inside. We'll push n mod 2, that is 1 onto stack. Then again, we will update our n variable. N variable will get updated by 9. Then we will again check this condition. We'll get inside. We'll push this n mod 2, that is 1 onto stack, because 9 divided by 2 gives remainder 1. Therefore, we'll push this element onto stack. After this, we'll update n by n divided by 2. Here, this will get replaced by 4. Then after this, again, we'll check this condition. We'll get inside. We'll call the push function. This time, 0 will get pushed inside stack. Then we will again update our n variable. This time, it will get updated by 2. Now again, we will check this condition. We'll get inside this while loop. We will push n mod 2 onto stack, which means we'll push 0 onto stack. Then we will update our n variable. N variable will get updated by n divided by 2, which means it will get updated by 1. Then again, we will check this condition. Again, this is not equal to 0, right? Let's call push function. This time, 1 will get pushed inside stack, right? Then we will update our n variable by n divided by 2, which means it will get updated by 0. Now we will again check this condition. Is n equal to 0? Yes, n is equal to 0. So we will get outside of this while loop. Function execution is completed. And you can see the current state of the stack. These are all the elements inside stack, right? 1, 0, 0, 1, 1, 0, 1. Now after calling dec to bin function, we'll call print function to print all the elements of the stack. We know that stack is global, so we can access this in this print function also. This is how our print function looks like. Here in this print function, I'm first checking this condition. If is empty, if the stack is empty, then print stack underflow and exit with exit failure status, right? Otherwise, simply execute this piece of code. That is, while not is empty, print the value returned by pop, right? So here, we'll first check this. Is the stack empty? If stack is not empty, not is empty means if stack is not empty, then continue and print the element returned by the pop function. Okay. So here we will get inside because stack is not empty. Now we'll call the pop function to get the topmost element of the stack. We'll get it and we'll simply print this on the screen. After this we will again check, is stack empty? Obviously not. So we'll get inside. We'll call the pop function. And after calling the pop function, we'll receive this value, right? In this way, we'll get all the values of the stack, right? And eventually we'll get this output on the screen, that is 1001101. This is the final output so obtained, right? And this is how our console window looks like. Enter the decimal number. Let's say user has entered 77. Then on the screen, of course, he will get this output 1001101, right? I hope the complete code and the idea behind how to convert a decimal number to its equivalent binary form is clear to you. Now it's time to execute the complete code in code blocks. Here is the complete program. We have is full function, we have is empty function, we have push function similar to the stack operations. These are stack operations only, basic stack operations, push, pop. After this we have deck to bin function. This is a very simple function, right? And then we have this print function to print all the elements of the stack. Inside this main function, I have declared a deck variable. I'm calling printf function, then scanf function, then I'm calling deck to bin function, and finally I'm calling print function to print all the elements of the stack. Let's enter 77. You can see the output 1001101, right? This is what we are expecting. Let's execute this once again. This time, let's say I want the binary equivalent of 100. 1100100. This is the binary equivalent of number 100. Okay? Let's execute it once again. This time, let's say I'm interested in finding the binary equivalent of number 2. We'll get 10 as the result, right? I hope this code is clear. Okay friends, this is it for now. Thank you for watching this presentation.